do you worry about how historical data that we use to train our models encodes past practices and behaviors related to these gaps in diversity and in pay?
A lot of the data sets that are out there weren't necessarily created with the intention of doing machine learning on them, and type in like, show me a CEO, and it will show a white man in a suit. We're trying to basically make like a general toolkit for people to have all the tools they need to make better decisions without kind of trying to tell people how to do that.
Erin, welcome to the Super Data Science Podcast. This has been a long time in the making. I've wanted to have you on the show for ages, and now you're finally here. It's awesome. Where are you calling in from, Erin?
Hi, nice to be here. I'm calling in from Oakland, California in the US today.
Nice. Well, so at H2O, you are the chief machine learning scientist, and you're creating an open source, distributed, automated machine learning platform. So I've thrown a lot of terms out there. Perhaps you can fill us in on what H2O does, what the chief machine learning scientist does at H2O, and then what it means to be building an open source, distributed, automated machine learning platform.
Okay, so H2O is both the name of the software that I work on, but also the name of the company. So H2O AI is the name of the company, and we have a number of different, basically machine learning platforms or products. But yeah, the one that I focus on is called H2O, the namesake, and kind of the original software that we were incorporated to produce. So yeah, I could talk a little bit more about that, but I think I'll just start with like, what is my title about? So I, at some point my title was just machine learning scientist. So when I first joined the company back in 2015, and I guess at the time I was the only, machine learning scientist there. Like everybody else were really hardcore engineers pretty much. And a couple sort of stats people, but yeah, my experience is really just designing algorithms and getting them to work fast. And so I focused on that. And then eventually, after just being there a long time, at some point you get promoted. So that's my new title. And I think actually I'm the only person still in the company with a machine learning scientist type of title. Most of the other people are software engineers or data scientists. So, and the data scientists work a little bit more hands-on with the data and helping customers. So yeah, my job is like, I do specifically work on one product, but I also sort of have been at the company a really long time. I'm one of the like earlier people joining the company that's still there. So I kind of know a lot of, historical knowledge about our products. And so I'm sort of an internal consultant in a way as well to help other people either interface with H2O or just do other machine learning stuff. I also do research. So that's just, another aspect of what I do. So I try to, make sure I know what's going on in the machine learning world and to try to take advantage of new algorithms as they come out and identify them and figure out how to maybe put that into our products. And yeah, so it's a lot of stuff. I used to do a lot of community work as well, like in the earlier days, a lot of meetups. There's a lot of webinars. I tweet about it. So all the jobs really.
Yeah, it sounds really exciting. You get to be involved in the development of some of the most powerful applications in a high-powered, well-funded, very popular machine learning company. So that's super cool. And then you also get to be involved with, it sounds like, lots of projects across the company by providing you the institutional knowledge that you've accumulated over the 8 years that you've been working there. And then, I don't know, I mean, you're you're kind of preaching to the choir here a bit with somebody who's a podcast host, but I also love talking about and spreading the good news about data science and machine learning like you do. So that sounds like a really fun part of the job to me too. And that is actually what drew me to you initially is you do create great content, you do amazing presentations at top conferences. The specific thing that drew my attention and it caused me to ask you to be on the show was that you'd posted this brilliant lecture that you'd given at NeurIPS, Neural Information Processing Systems, which is the most prestigious machine learning conference around. And yeah, you're doing keynotes at places like that. I'm honored to be speaking to you, and it must be so fun being able to do those kinds of things. So, so we've talked about H2O. We've talked about what it means to be the chief machine learning scientist there. Tell us about the open source distributed automated machine learning platform that you're responsible for developing.
Sure. So the platform is H2O, and I've been involved in just generally H2O for a while. So not the AutoML stuff before that. So just every aspect of it, like what the API looks like, what the algorithms do, like what kind of details do we store in the model objects, like anything related to that, I've been involved with since the beginning. And so that just is a foundation for the automated platform. So basically that's just a whole bunch of algorithms, all the good ones, none of the bad ones. So, your friends like GVM or XGBoost or Random Forest, we have some deep learning, not as extensive as like a PyTorch or a TensorFlow, but basic sort of deep learning that works on tabular data. And, there's a whole bunch of them. I'm not going to list them all. We have a lot of unsupervised algorithms as well, anomaly detection, things like that. So that's kind of just the foundation. So we have all these algorithms. And now, so after kind of we finished that part, I was sort of noticing that I kept writing the same code over and over again to, new data set, like let me try my whole thing and try all the different algorithms, do grid searches, other random searches, just do as much searching as possible, then kind of bundle all that together with a stacked ensemble to get the best performance. And so I was already kind of doing the same thing over and over again. And so then that...
You were an AutoML algorithm.
Yes. I mean, everyone is. So not everybody what goes on and creates a whole software around it, but like you should, because that's what I did. So basically that became H2O AutoML. And now it's just this sort of algorithm / wrapper function that just does a whole bunch of tasks. And it's, will modify itself based on resources. Like if you only have short amount of time versus a long amount of time or things like that, it will modify itself. And so the goal after we first released that in 2017, and, at the time it was basically, Teapot and AutoSKLearn and maybe like a few other open source libraries that, are not as popular. And so the AutoML space was a lot different than it is now. So yeah, it was, in my opinion, like H2O is a platform that's designed to be very robust and fast and like enterprise level, low memory, like all the optimizations that you would want in a machine learning library. So I think H2O AutoML represents kind of the first enterprise sort of ready AutoML system, at least in the open source. I can't say what else is out there otherwise. So yeah, that was kind of the goal.
And then so if this amazing, robust, optimized AutoML tool is open source and any of our listeners can be going out and using it, how does H2O make money?
That's a good question. I should check on that. No, I'm just kidding. So the company started as exclusively open source. H2O was the only thing at the beginning. And in the beginning, we did enterprise support contracts, sort of like focusing on big clients like big banks and insurance companies, healthcare companies, people that can afford to pay for something essentially that's free. Um, so that was kind of the first revenue stream. Then we wanted to add more revenue streams. Of course, we're a VC funded company, so that's how things go. So then we created a whole additional proprietary platform called Driverless AI, which is another AutoML platform. There's some similarities and differences between the one I work on and that one. I won't go into too much detail unless we want to revisit that, or maybe we'll.
Go into it. That's kind of interesting.
Okay, sure.
So, like, I'm kind of guessing maybe it leverages some of the ideas, the open source things that you're doing with the main H2O AutoML library, but maybe there's some. I'm guessing if I was doing this, I might want to be having some bells and whistles that specifically cater to enterprise clients, like security features or something like that.
Yeah, so the algorithm itself is a little bit different, but it's a lot of it's also about the additional features that sort of help you operationalize things better. And like fundamentally, they're both sort of ensemble algorithms. One of them, so driverless AI uses like genetic programming to do very extensive like feature selection and feature creation. So it's kind of like an automated feature engineering piece to that, which, obviously helps with performance. So that's like probably in terms of just the algorithm itself, like what is the difference? In the open source, we do some like feature processing, but not this sort of proprietary thing so one of the things about H2O is that we've hired a lot of Kaggle grandmasters, and they're the ones who are like very good at this kind of dark art of feature engineering. And so they are the ones that kind of came up with the automated feature engineering. So that's one thing. Driverless AI is also more focused on GPUs, whereas H2O is CPU.
Got it.
But in a sense, they're quite comparable. So yeah, it's just sort of what you're looking for. Usually, people kind of have either they use both or they just use one of the other. And so that's another revenue stream. And then the last thing that we have now is the H2O AI cloud. So that's a whole nother business basically within H2O where it just makes it, I think we could have even done this years ago, but like people, we were more focused on building the actual algorithms themselves. And so now we've kind of done that, and we are still iterating and improving, but this just is like the next iteration of, okay, now we have all this good software and machine learning algorithms, like let's make this a lot easier to use on the cloud. And so we kind of just have our own cloud. Because of course you can use either tool on whatever cloud you want, but there's just a lot of like model tracking and governance and other features that you would get.
Today's show is brought to you by Datalore, the collaborative data science platform by JetBrains. Datalore brings together three big pieces of functionality. First, it offers data science with a first-class Jupyter Notebook coding experience in all the key data science languages: Python, SQL, R, and Scala. Second, Datalore provides modern business intelligence with interactive data apps and easy ways to share your BI insights with stakeholders. And third, Datalore facilitates team productivity with live collaboration on notebooks and powerful no-code automations. To boot, with Datalore, you can do all this online, in your private cloud, or even on-prem. Register at datalore.online/SDS and use the code SUPERDS for a free month of Datalore Pro and the code SUPERDS5 for a 5% discount on the Datalore Enterprise Plan. Okay, cool. So the H2O AI Cloud, it can be deployed to any of the major cloud service providers like AWS, Google Cloud. So it allows model tracking and other kinds of governance features like you're describing in any of those physical clouds?
So yes, and with the caveat that like we can also just do everything on our own cloud, which is hosted on Amazon. We have that, but we also have like what's called like the hybrid cloud, where it's sort of also on-prem, so you can kind of choose
Right.
whichever meets your needs.
Awesome. So we've got, in terms of the H2O product universe, we've got the original eponymous H2O open source library, which is what you're focused on primarily.
Mm-hmm.
And any of our listeners can use that AutoML library right now.
Mm-hmm.
Go access it on GitHub, use that library.
Mm-hmm.
We've also got the driverless commercial package, which also does AutoML, and it has automated feature engineering features. And it works well on GPUs, so it's optimized for GPUs. And then we've got, finally, you mentioned there, the H2O AI Cloud, which allows distributed training to happen on either on-prem with the client's own cloud with their own servers, or on a third-party cloud, or even H2O's own cloud service. So that's super cool. Let's dig into just a little bit more some of those terms. When we were talking about driverless, we were talking about, we don't need to dig into this too deeply because some of our listeners will be aware of them, but others might not be. So let's talk a little bit about feature engineering and why it's important to have algorithms potentially be able to work on GPUs. So, the feature engineering is critical for a lot of models because, and you can explain this better than me, but just kind of giving you a starting point, it allows us to take however the raw data is provided to us and then run functions over those data to extract the features that are most likely to provide the most valuable signal to the machine learning algorithm downstream. Does that sound like a reasonable description?
Yeah. Yeah. And so the specific like genetic algorithm that's used, it sort of automatically creates a bunch of candidate features and then kind of evaluates their usefulness. And then, does that in kind of the genetic algorithm type of way.
Let's talk about that a little bit too, because that's really fun.
Yeah.
How do these genetic algorithms work?
Well, I guess I can't say specifically how the one in driverless works because that's our thing.
Right,
but
right.
yeah, I mean, genetic algorithms, the way they work is sort of, there's like an evolutionary process and it sort of goes through the different stages of evolution, and like whatever sort of left at the end is like what you come up with. And, it just uses standard ways to sort of evaluate model performance during the process as well. So yeah, I mean, I've been seeing, I mean, they've been around, that the concept has been around for a long time. It's just, I've been seeing a little bit more of that lately with, people using it in different machine learning applications.
Yeah, it can have really cool impacts. It can solve in situations where other kinds of approaches like stochastic gradient descent, kind of standard machine learning approach, might not allow you to converge on an optimal solution. Genetic algorithms can sometimes still do really well in those situations. And I think to dig into it a little bit more, so it follows an evolutionary process, meaning specifically that you start with kind of like random starting points on a whole bunch of different situations, and then you take the best performers that just happen to randomly perform best at your task, and then you mate them together. So you randomly take the best parts of one of your top performing algorithms from the first iteration and another one of the parts of one of your top performing algorithms from that first iteration, combine them together randomly, and then you see how all these children perform on the task. And then the top performing children, you mate them together. And after many generations of mating all these children together, you end up with descendants that just happen to, by chance, perform really well at whatever task you're trying to get them to do, like in this case, feature engineering. I think they're really fun. I've never really deployed them in any production situation, but I guess I know a little bit about them, and they're super fun. I'd love to find a use case. So that's the feature engineering with genetic algorithms. And then you also talked about how the driverless package works well on GPUs. So why might somebody need to be doing something on GPUs as opposed to just CPUs?
Um, it depends. I think it just depends on the software you want to run. So, um, and sort of the size of your data and sort of a lot of different things. But um, for driverless, one of the algorithms under the hood is XGBoost, and that's can be like it's a software that is optimized for GPUs, or you can run it on CPUs or GPUs, but can run a lot faster on GPUs. The other thing is like the genetic algorithm, like that's kind of a beast. So like want to just throw as
Mhm.
much compute at that as possible. So yeah, I mean, they're more expensive, they're more resource intensive, but they can also just, solve problems quickly. So,
Mhm.
it's just kind of whatever works for you. Some people don't have a
Mhm.
GPU. You can rent them, but they're a little expensive to rent on the cloud. Um, so yeah, and because H2O, the OG was created in 2012, the company was founded. So if you can kind of remember back 10 years in the data science world, like everything, well, Amazon EC2 was like newly becoming like a popular thing. And it was like all of a sudden we could get very, very cheap CPUs, like widely accessible. And so that was kind of one of the goals is like, let's build a library that can take advantage of that compute infrastructure at the time. And fast forward 10 years, like we have a lot more advances in GPUs and yeah, there's a lot of things you can do with both. H2O also can use GPUs when you're using XGBoost, but that's the only third-party algorithm that we have incorporated in the tool, and also the only one that can take advantage of GPUs. So
Well, and I'm not surprised given all the Kaggle grandmasters at H2O that XGBoost happens to be the algorithm that gets all that extra attention because XGBoost is often the winning algorithm in a given Kaggle competition. And probably many listeners are aware of Kaggle, but so we've mentioned that a few times now, but it's a platform that we'll be sure to have in the show notes in case you aren't aware of it. It allows you to test your chops at solving data science problems against other people around the world. And the top performing algorithms in those competitions are often XGBoost. And the people who regularly top these competitions are Kaggle grandmasters, like chess grandmasters. And yeah, H2O is famous for hoovering up all those grandmasters.
yeah, I mean they also like Light GBM and sometimes Cat Boost, so I'll just give them a shout out as well. Not just XGBoost, but yeah, like a lot of people like Light GBM too.
That's true. Yep, yep, yep. Um, and so, all right, so I've forced you to kind of go off piste and tell us tons about driverless and the H2O AI cloud. Let's go back to H2O proper, the open source tool that you're primarily responsible for. So I know that part of this is something that you are into encouraging users to do is to use the auto explainability feature to make sure that there's still a human in the loop for important model choices. So why is that important and how do you nudge people into the direction of using that auto explainability feature?
Yeah, so in the open source, we have kind of like an automatic explainability, kind of just like a wrapper function. It's a function, but it's really just iterating through a number of like what we call explainers that are available in the tool. And really, that's just it's not meant to kind of make people not have to think. It's more like just write one line of code instead of a bunch of lines of code because that's kind of something that I like to do is wrap things up. So yeah, I think the idea is like you generate it with like one line of code and then you get a whole bunch of explanations. But the explanations are technical. So there are things like Shapley plots or partial dependence plots or things like that. So you have to actually be like some level of data scientist to understand what it's saying. So I think we're very far away from any kind of automated, decision making type thing. Or so yeah, I think in that sense, like the human has to be in the loop because there's nothing more to do with it other than to then interpret, and you have to know a little bit about each of these different types of explainers and what they're good for and what they're telling you. So yeah, I think, but just sort of on the human in the loop topic, like there's other ways to kind of handle that. So there's like if you have like a model governance platform, for example, you could have things kind of, models generated automatically, then explained automatically, but then also you would have to you could set up some kind of controls where, certain people with certain positions at the company have to like approve things and things like that. So I think that that's kind of, that there's other things that we're doing in the cloud that makes it a little bit easier for non-data scientists to do that kind of thing. So there's a new thing that we have coming out called narrative explanations, where it's basically just words and it's kind of explaining what's happening with words so that a non-data scientist could try to make sense of that, like a business leader.
Nice. That sounds really cool. So we've talked a lot about AutoML and how how this H2O open source product allows people to do it. And you even talked about how the genesis of that AutoML tool was you being kind of an AutoML algorithm yourself. So if our listeners aren't yet using AutoML, why should they be considering it? And a related question is, can you please explain to us your no free lunch theorem?
Okay, so first, why should people use AutoML? I think because it's a tool that can be useful for anyone, like regardless of where they are in their data science career. It's useful to like somebody like myself. Like that's why I wrote it, because I wanted to have cleaner code. Like just I knew what I wanted to do. It was pretty much the same process every time. There's like variations on it. Which are now sort of bundled into the algorithm. But it just makes everything really cleaner, like more reproducible. You just get it, we generate what we call a leaderboard. So that's like an idea kind of from Kaggle, where you have everybody ranked. So in this case, we just rank all the models by whatever metrics you're interested in. I think it's just kind of automating kind of not the hard parts, but almost like the boring parts of experimentation. I think people, when they're learning algorithms, that's a good thing to do because you want to kind of investigate more, on a manual level. Like if I change this, like how does that affect? And you kind of build up this intuition over time. But for somebody who's kind of got their thing down packed about like how they approach a data science problem, it's just less code basically. And then for people who are not as experienced, it can actually be like a learning tool, I think, because you have this easy function where you just run it and then you get to see the results and you're like, okay, this is interesting. Like, why are the, GBMs on top and the deep learnings below? Or, you kind of start to notice trends in the leaderboards and like which algorithms perform well. And then you can kind of look at, okay, here's the top 3 models are like XGBoost models. Like, let me go ahead and then look at the hyperparameter settings and what's different about these versus that. And then you could even have more context that you might not even think to address. Like, for example, prediction speed is something that if you're using machine learning in the enterprise, it's something that you might care about. So it's not stuff that new data scientists always think about. So if you have this leaderboard and you have models ranked by model performance, and then you also have a column with, prediction speed, and then you start to look at things, you can see, like what have I learned about like very deep trees? Oh, they're slow to predict. So like, let me, keep that in mind when I'm building things. So like there's little sort of nuggets that sort of automatically bubble up to the surface that I think you can learn from. And then, you don't have to be an expert on every single algorithm, because you might be very good at, like, let's say, just XGBoost, but you don't know how to do anything else. Like there's a lot of people like that out there. If you're going to pick one tool, like it's not a bad choice. So, it takes a long time to become an expert at a single algorithm. So then with the AutoML process, you get all the algorithms basically, and you don't have to know, like if you don't know anything about deep learning, that's okay, because we've already thought about like what would make sense to do there and sort of generated what we think is useful. And then it can, also just be used as a baseline. You could just start there and like see what you could do on your own to kind of outperform the AutoML.
What do you think about the Super Data Science podcast? Every episode, I strive to create the best possible experience for you, and I'd love to hear how I'm doing at that. For a limited time, we have a survey up at superdatascience.com/survey, where you can provide me with your invaluable feedback on what you enjoy most about the show, and critically, about what we could be doing differently, what I could be improving for you. The survey will only take a few minutes of your time, but it could have a big impact on how I shape the show for you for years to come. So now's your chance. The survey is available at superdatascience.com/survey. That's superdatascience.com/survey. Super cool. I had never thought of how valuable that kind of AutoML leaderboard is for learning about algorithms. It's a super cool application that I hadn't thought of. I always think of the things that you did mention as well, like it making model development easier, less boring, cleaner code. Those are all the kinds of things that I expected you to say. I didn't expect the model leaderboard answer, which was so illuminating. And I can definitely see how that would work. It would be so interesting as somebody getting into data science, or even, like you say, somebody who's maybe expert in some specific algorithms and not others, to see how all these algorithms compare against each other with respect to model accuracy as well as efficiency. Very cool. I like that. And then, so Erin, what's the no free lunch theorem?
So the no free lunch theorem is it in the machine learning context. It's like a theorem. There's a paper related to it, but it's one of the authors is this guy named David Wolpert, who is one of the inventors of, or is the inventor of stacking. So that's stacked ensembles. So probably the reason that he came up with such a thing is because he understood kind of this, where he had this kind of notion about algorithms, and the no free lunch theorem states that like any optimization algorithms or any two algorithms are like equivalent over if you average over like all the problems that they could be applied to. So there's sort of like no one best algorithm is kind of the other way to think about it. And so that's kind of the approach that you take when you're a person who does stacking. You're kind of like, well, there's not well, first of all, there could be a single best algorithm on a specific data set, but you don't know that in advance. So what we like to do is just try a whole bunch of things on a bunch of different algorithms and then stack them together. And that's actually going to give you, in a reliable way, like better performance than like if you just choose GBM all the time or something like that. So that's kind of where it comes from. And yeah, there's no trick. And that's true of like AutoML tools as well. Like there's not just going to be one AutoML tool that wins on every single problem. It's just like more levels of that.
Right. But AutoML is kind of a step in the direction of evaluating at least all of the possible models in the universe. Maybe not in the universe, but all the popular algorithms that are likely to be useful. So, so AutoML is an avenue to try to minimize the impact of the no free lunch theorem. So to kind of state back to you something that you already said, you could have somebody who is expert at XGBoost or expert at GBM, and so they are always looking to use that hammer on any nail that they confront, even though there could be situations where, deep learning actually would have been a better choice here than XGBoost or GBM, or maybe even some because of characteristics of this particular problem, a really simple logistic regression model is just going to be able to do it super efficiently and get you the same kind of accuracy anyway. So the no free lunch theorem is that no one single hammer is going to be the best hammer when you encounter any possible nail.
Correct.
I guess a better
Yeah.
analogy would be that like some models are like hammers, some are like saws,
Yeah.
and you encounter different kinds of situations in this home building exercise analogy for some reason. Uh, and and yeah, so AutoML is a step in the direction of being able to try out all those different tools given the new situation that you've encountered for the first time. But then it was a really nice couch overall for you to mention that even then, a given AutoML tool like H2O, while it presumably endeavors to be as broadly useful as possible, there will inevitably be some situations where some other AutoML tool might actually be able to outperform it.
Mm-hmm.
And you talked about stacking a little bit there,
Mm-hmm.
and so that might be a term that that listeners aren't totally familiar with, but we can actually put a pin in that because I'm going to be asking you some very specific questions about stacking later on. So, listener, don't worry, we will get back to that. Before we get there, I wanted to talk about a concept that you've been promoting called admissible machine learning. And I had never heard of that before I started doing research for this episode. So, can you fill us in on what admissible machine learning is?
So yeah, so admissible machine learning is a new topic, which is why you haven't heard of it yet. So there was a paper in the journal Machine Learning that came out in January 2022. So that's this year for anyone who's watching, I guess,
In the
in the
future.
future. Yeah. So yeah, that. It's not super well known. So this is something that we are the first people to kind of implement. So there's not like there's not admissible machine learning in scikit-learn or anything like that yet. So this is and H2O is the only place that that has it. So kind of the idea is, we were thinking a while ago about like what could we do with regards to fairness, the topic of fairness in machine learning. And this is kind of, we're working with like a consulting researcher who, came up with this whole very dense, very theoretical foundation for what's called now admissible machine learning. And so it basically relies on like information theory and non-parametric methods. One of the things that it makes extensive use of is the conditional mutual information calculation. And so the idea is, you have your set of predictors like X, you have your response Y, and then you might have some other variables that we consider to be like sensitive. So that could be something like gender, race, other demographic variables, which could either be sort of either regulated in some way, like in the, lending industry, it's like fully regulated that you cannot use anything deriving from that. Or just maybe you're just trying to make better models that are not discriminating people on, various properties. So yeah, the idea is like the mutual information of Y and X given these sensitive variables will be zero if and only if like there's like basically there's no sort of leakage from the sensitive variables through X into Y. So like what happens often is like you have your predictors, which don't look like they kind of have anything scandalous in them. Then we have the sensitive or protected variables, and they do. But then a lot of times, like kind of if you draw like a DAG, like a directed acyclic graph, kind of going through where everything is influencing everything else, like you get, still information coming through the X variables that are from the sensitive ones, even if you remove them from the training set. So the idea is like we can kind of come up with like a metric for how much the sensitive variables are sort of leaking through the other ones. And then we can kind of rank things based on that. So rank models, like And that can be kind of used. So one way that we use it as kind of a feature selection algorithm. So what it can do is identify, like, of your what you think are your safe variables, are there any that are kind of, let's just call it leaking that information. And so one thing you can do is kind of apply it as a feature selection method where you just remove those ones that have, beyond some threshold that you're comfortable with in terms of mutual information. So
Mhm.
yeah, so that's kind of the main application of how you might use this. And then the goal there is then, you're training models on this more like this subset of the original data set. And then ideally they should be more fair based and when I say more fair, that's like a very vague not well defined term, but that's up to the user to decide, like, what kind of fairness metrics are you interested in, what do you care about, what's okay, what's not okay. We're trying to basically make like a general toolkit for people to have all the tools they need to make better decisions without kind of trying to tell people how to do that. Like, we don't want to try to do like automated fairness, for example. I think that's like probably a bad idea. So yeah, that's kind of the idea behind it. And there's yeah, in H2O there's something that we call the infogram, and that just is a graph of, like, basically it's sort of like variable importance on the x-axis, and then this net information that we call it on the y-axis. And you can kind of look at, like, it gives you a tool also to kind of decide, okay, if I'm choosing between these two features that are kind of leaking stuff equally, is one of them not even that important? Like, so it gives you kind of like this visual tool to say, okay, this is great. It was a bad feature anyway. It's not even actually that valuable. So, like, let's get rid of this one, but like maybe let's keep this one, or things like that. So yeah, it's kind of just a whole set of tools. And so basically, if you want to learn more, go on the H2O, like H2O user guide, and there's a section called Admissible Machine Learning, and that will have a link to the paper, and you can read more about it.
Nice. Super cool. I just learned so much about this new topic that as I was saying, didn't know anything about before researching this episode. And I'll try to recap back to you what you said, and you can tell me what I get wrong.
Mm-hmm.
So, admissible machine learning relies on information theory and non-parametric methods to quantify how much sensitive variables are influencing the model outcome Y via the inputs X.
Mm-hmm.
And so this allows us to potentially remove features that are associated with these sensitive variables that could be associated with unfairness.
Mm-hmm.
Is that a reasonable recap?
Yeah. Yeah. And so then the idea would be, like, if you're building on a subset, like, hopefully you're kind of removing some of the bias, at least. There's other, I think with all these problems, like, there's a lot of different ways to attack the problem, like on the data, on after you train the model, et cetera. So, like, it could just be one tool in like a whole suite of things that you try to get rid of the bias.
Nice. And then the H2O infogram enables visualization of everything that you've just been describing. And so it allows people to be, making these evaluations, potentially removing some unfairness, some bias from their modeling approaches.
Yeah.
So, tangentially related to the topic of unfairness or bias is that you've founded or co founded two massive and highly respected organizations to champion and promote underrepresented communities in the field of data science. So, you founded Women in Machine Learning and Data Science, and you co founded Our Ladies Global. And so, I'm actually indebted to you personally because Women in Machine Learning and Data Science was my initial break in the speaking circuit. So the New York community for Women in Machine Learning and Data Science was the first meetup that gave me a shot at giving public meetup talks. And so, that was kind of like a starting point that I was able to leverage and say, hey, I did this talk. Maybe you'd like to welcome me and do a talk with you as well. So thank you very much, Erin, for creating that spectacular community. This was before the pandemic, and so I'm sure things have changed as things have become more virtual.
Mhm.
But pre-pandemic, it was such an engaged community. You saw the same people coming out to meetups regularly and supporting each other around learning machine learning concepts, around getting great employment opportunities in data science and machine learning. So, great organization. I'm less personally familiar with Our Ladies Global, but I know that it is, I see it everywhere. So, yeah, truly it's remarkable to have been able to found or co-found these two massive organizations. So, what motivated you to create them, and what challenges did you overcome along the way?
Well, it's great to hear that story, by the way. I'm glad that, I mean, we hope that this is a venue for people to kind of get experience and then they can go, it's exactly that. And yeah, so I'm glad to hear that. So why did I found each of these? So the Women in Machine Learning and Data Science was founded in 2013. And the idea for it comes from the Women in Machine Learning workshop, which is at NeurIPS. And I went to that in 2012 and then 2013 as a grad student. And I just thought, like, this is so great. Like, but if I go back, I don't have this community as much. They do a little bit more online stuff now, but like back in the day, it was like a 1-day conference once a year, and it was exclusively focused. Well, I shouldn't say exclusively, but primarily focused on academics and a lot of grad students. So at the time, I was going to a lot of meetups, and they're mostly men there. So I thought, why not try to make this women in machine learning concept to be a meetup, and then we can meet, once every 2 months, or meet the women community basically. And yeah, so I just kind of, I don't know, just was like, I think I waited like a year, and I was like, if somebody else will do that, that'd be cool. And then like it didn't happen. But then, so like right after NeurIPS in 2013 and the Women in Machine Learning workshop, I went like on Meetup, just like created a Meetup, and I call it Bay Area Women in Machine Learning, and I added the and data science because I did want to kind of extend to just more software, data science, just generalizing it a little bit. And way back when we did have like a few talks like with the WIML, well, at least one person at WIML that was like, okay, maybe we could like do chapters of WIML, but that it kind of just never panned out. So I just kind of took it, on my own and did it. And yeah, like there was probably like 15 people that came to the first meetup, maybe, so yeah, then we just kept doing it. And a couple of years later, somebody in, I think it was, New York was, I think, the second chapter. So someone in New York just contacted me and said, hey, I like this thing that you're doing. Like, could we do one in New York? And, I was really excited that like anybody cared. And so then that's when the New York chapter started. And I think like maybe like a year later, one in North Carolina started. And then I don't know, just over time, there's like a lot now. So there's like 100 and something.
Wow.
Yeah. So we tweet a lot at WIMLDS. And so I think that's maybe where people find out about it these days. And then they see it online and they think, okay, we have stuff on our website, like contact us if you want to start your own chapter in your city. And, we pay for the meetup fees and like all the infrastructure. So you basically just kind of focus on running your own group. So yeah, I guess the goal was to create this community beyond just like a single day of the year and kind of expand it a little bit more and kind of make it localized so you get to know your local folks. And then
Super cool.
yeah.
Yeah, and then Our Ladies.
Then Our Ladies. So Our Ladies Global is basically a nonprofit that is very sort of in spirit, very similar to like Pie Ladies. So that's another one that's where the name comes from. Yeah. So it's groups of people that are interested in learning R and using the R language, and it's a little bit the same vibe as women in machine learning and data science, but just exclusively focused on R. And that kind of came together there's a yearly conference in the R world called Use R. That's kind of the big conference once a year. And so me and I think it was 5 other people, could be 6. I can't remember how we were counting because people kind of dropped out a little bit. But, me and maybe 5 other people getting together. And there was one chapter already in San Francisco that was, existing. And then some people from London met us from San Francisco at the Use R conference. And then we're like, well, we want a chapter 2. Like, how do we do that? And then other people at the conference were like, well, we want a chapter. So then it just kind of became very big very quickly because everyone's like, oh, we want that too. And so we just, started a nonprofit, applied for some grants to get money to pay for the meetups. Because, meetup.com is not cheap.
Right.
Don't know why, but anyway, it's that's a whole nother rant I'll go on. But anyway, it's super expensive for what it is. But everybody's on it, so it's a good place to launch meetups. And so we basically, we spent a lot of time at the beginning just on developing kind of the values that we wanted in the organization, and like what would be okay, what's not okay, like. Some of the things that are like important to us is like no commercial agenda whatsoever. So like one of the things about women in tech groups is like there's always companies that want to come and like use you to get sort of diversity points in the world. So like we didn't want that, or like promotional stuff. So like everybody was kind of on the same page in terms of values of like what we were trying to do here and what was okay and not okay. We spent a lot of time on branding at the beginning. I remember like looking at many hex codes of purple and like voting on which purple was the best purple for the R. So like, and we had people that were good at making logos or branding, and then we have somebody running the Twitter. So I think that's probably why you see them everywhere. We did like from the beginning kind of put a lot of focus on brand and consistency, and like we wanted kind of the same values propagated through all the chapters so that it's not just sort of this disjoint thing. So it's a little bit, PyLadies is a little bit different in that it's a little bit more decentralized, whereas R-Ladies is a little bit more centralized. And there's kind of one group that's kind of running the show.
Kind of like how R has a central CRAN repository.
Yeah, which we know is good. There are good things and bad things about that. Yeah. Oh, what a horrible comparison.
Sorry.
Oh man, never been compared to CRAN before.
All of the R-Ladies meetups must have a PDF in exactly this format, and it must be approved to get it. No, I'm joking.
No.
So amazing organizations, Women in Machine Learning and Data Science, and R-Ladies Global. Thank you so much for founding and co-founding these organizations, respectively. They make a huge impact worldwide. And so obviously for our female listeners out there, these are organizations that you should be thinking about getting involved with. But also for other folks, like I've been involved with Women in Machine Learning and Data Science as, there's ways that you can help out even if you aren't female, for example, by giving talks to these organizations. I'm sure there's other ways. Really amazing organizations. Thank you so much, Erin.
I'll just say one thing on sort of the topic of like who these communities are for. So sort of back 10 years ago, we weren't thinking a whole lot about, it was just like women is what we were focused on. And now I want to be clear that we're open to basically, we're open to everybody. Anyone can come to our meetups, but we do try to promote women and non-binary speakers, not exclusively, but the idea is that that's who we're trying to help. But I just want to give a shout out to the non-binary folks who may not feel represented.
For sure. Thank you for calling that out. And so a related question, kind of tying your work as a grassroots community leader in these organizations, as well as your machine learning background. Um, so there are gaps today, well publicized gaps in diversity and income in a lot of industries, including in machine learning and data science. Um, and um, and while we hope that in the future those will be completely resolved, do you worry about how historical data that we use to train our models encodes past practices and behaviors related to these gaps in diversity and in pay? How do you think we should address bias in data sets and the data generation process? I mean, I guess we have some, now I know about admissible machine learning. So that sounds like one really cool way to be doing it. Do you have any other thoughts on that topic?
Well, yeah, first of all, I do think it's a big problem because, yeah, pretty much a lot of the data sets that are out there weren't necessarily created with the intention of doing machine learning on them. And there might be, the data is created in a weird way that could encode biases, or there is just historical bias like represented in different industries that's getting encoded into the models. So yeah, it is a huge problem. I think people have been talking about this a lot for, I don't know, very much a lot in the last 5 years at least. It was talked about before then, but yeah, I'm really noticing like more prominent people speaking out about this. But like there hasn't really been any like huge progress. Like we still see like brand new systems like that were just designed like in the last year, like some of these image generation platforms like Midjourney, Dolly, etc. And they have like really objectionable content in there. Like if like a vanilla example is type in like, show me a CEO and it will show a white man in a suit. Like that's just same with Google Images. I mean, I guess, yeah, it's concerning because at this point we know all of this and there's still not anybody really regulating it in any way. And it's kind of a weird situation to be in because we're kind of trusting, I mean, not that we are doing this intentionally, but like the way that society is set up is we're trusting the companies that are producing these to kind of self-police. And I don't think they are. I think they sometimes respond to things when there's like some kind of media, thing about, oh, this system did this and it's, racist or sexist or whatever. And then they say, oh, we've been working on that. We're trying to fix it. And it's like, but they like we have all the tools and the researchers who are knowledgeable about the stuff that work at all these companies. So I don't know, there's a disconnect there. So I don't know really, and it's hard to kind of measure these things anyway. Like how fair is this? And like, if it's below this threshold, we're going to trash it. Like there's not really an easy answer, but it's just, hopefully, I mean, the thing that I'm doing, because this is my skill set, is trying to make tools that can make this stuff a little bit easier so that it's not this mysterious thing that you don't know about and it's just right there in whatever library you're using and you start to learn more about it that way. So I think, yeah, we have a long way to go. And then, once the data scientists know a little bit more and have the tools, then we have to kind of figure out the other piece, which is, if it's more profitable to show this type of thing, even though it's racist or sexist, it's probably still going to happen because that's just capitalism. So, yeah.
Yeah, it is. It is somewhat encouraging to see in recent years that conferences like NeurIPS have tracks specifically focused on these bias issues, which prior to 5 years ago, you didn't see at all. It was really a fringe topic. And so it is, hopefully encouraging that it is something that is being discussed. However, as you say, it's amazing how so many major production algorithms that come out today still have these issues. And so I guess, 5 years, I don't know if there's just not enough of a sense of urgency, even though these are important issues. I think perhaps part of the issue, which will take some time to resolve, is that these algorithms that you're describing, the people who are working on them are still disproportionately white men. And so they get released, and these kinds of issues like you're describing about using an image generation algorithm and typing that you want to see a CEO, and it comes out as a man, and they don't bat an eyelid at that.
Mm.
And so I don't know if that's like part of the issue, and hopefully that, I don't know. I guess the whole, like, there's a lot of different parts of these historical systems that reinforce these issues, and yeah, it is disappointing that we're not making faster progress, but hopefully hopefully at least by having all these conversations, um, more meaningful strides can happen more and more in the future. Yeah, I don't know if you have any other thoughts on that.
Yeah, I think like the last thought would be, rewarding people for looking at these topics is a big,
Right.
important thing. So like it's a big deal that NeurIPS had this new datasets and benchmarks track last year, which is the one that I gave the keynote at. And yeah, I mean, a lot of the people that work at the big research labs, they need to publish papers. And so if they're not able to publish papers at the top conferences on these topics, then they're probably not going to work on it or be less inclined to. So I think that was a big step. And, I hope that track can grow. And I'm glad that it's like become, I'm also like very passionate about the benchmarking side of things because I don't know, I like justice. So it's just like, I like things to, I like it to be clear where everything is. And like, I don't like a lot of marketing. I like numbers. So yeah, I think that's a big contribution. I'm happy that NeurIPS did that.
Nice. All right. Thank you for that insight at the convergence of both your community involvement as well as your machine learning expertise. Really nice to be able to ask you questions and get your expert perspective. So moving on to another part of your expert perspective, something from the past, prior to what you're doing now at H2O, you were doing a PhD at University of California, Berkeley. So at Berkeley, your focus was to reduce the computational burden of the stacking. I promised we would get back to stacking of the stacking methods developed by your advisor, Mark van der Laan, to scale machine learning to very large data sets. So could you explain this topic of stacking methods, and then maybe more specifically your research on how you were able to adapt stacking methods for very large data sets?
Yeah, sure. So yeah, that's kind of one of the things that I focused on in my PhD. And it really just kind of came about from just using the software that was available to do stacking. And it was just taking like a really, really long time to run my models. And there's like one point where I calculated it was going to take like 2 weeks to run like this model that I wanted to run with like multi-level cross-validation and stuff like that. And so, yeah, I was just a little bit like, I think one of my first classes at Berkeley was with my advisor, and he, introduced what he calls it the superlearner algorithm, because he has a paper called Superlearner, which basically proves all the theory behind stacking and why it works. So stacking existed a lot like earlier than people knew how exactly it worked and were able to publish like theoretical guarantees of performance and things like that. So that's why he calls it the superlearner. So he's, presenting this algorithm, and he says, this algorithm provably does better than any single algorithm. And I, raised my hand and I'm like, okay, well, if that's true, like, why have I, first of all, never heard of it? And second of all, why isn't everybody using it all the time? Like, if you had one algorithm that was always better, why wouldn't you just use that one? It doesn't make any sense to me. And he's just like, I don't know. I don't know why they don't use it. So I was like, this doesn't make any sense. So, I kind of like early on, actually before I went to Berkeley, I knew about Superlearner, and I just didn't understand why people weren't using it. But then I started to try to use it, in my research. I also did some applied research, and it was just, it was slow. It was, training a whole bunch of algorithms in R,
Right.
and all the code was in R. And so it was just, it wasn't scalable to big data sets. And I worked in like biostatistics. So a lot of the data sets are smaller anyway. So people aren't testing it on like, million rows or anything like that. So,
Right.
basically I just was like, this needs to have a better user experience. Cause I like the algorithm, but it's like not working for me right now, the software. So one of the things I did was discover H2O around that time, which had an R library.
Ah.
And so that was through like some other projects and benchmarking and another startup that I used to work at. So I discovered H2O, and I realized through like extensive benchmarking that this platform is really fast, really low memory, like has a bunch of algorithms, not as many back then as we do now. But I
Mm.
was like, maybe instead of using a bunch of random R packages that are implemented by all different people with different skill sets, and some of them are really slow, you don't even know which ones are slow in advance. So basically I saw that as a platform that I could develop the super learner / stacking algorithm on top of, because it didn't have it. So I started, just writing that code and making, making that software. I didn't like. I first started out as an R package that was using the H2O R package. So all the
Mhm.
code I wrote was in R, but really it's just kind of instructional code. It's not just saying train this algorithm and then take these cross validation folds and do this with them. And it didn't really matter in terms of performance. That was written in R, but it was as an R package. And then eventually I graduated and then went to go work at H2O, and then we re-implemented everything in Java. So H2O is written in Java, but it has all the algorithms are written in Java, but the APIs are Python and R is how people mostly use it. So we got it all, super optimized in Java with some Java engineers that I worked with. And and so then that was one approach. Then there was a couple other things. There was another algorithm that was called subsymbol, which is kind of a version of stacking, but it's partitions the data set into subsets and then uses this kind of fancy version of cross-validation where it's able to you're able to score all the rows like you need to in stacking, but you're able to do that with like training on smaller subsets. And it actually does pretty well compared to if you just use the whole data set. So that was another approach. And there's an R package that does that. It would be great to have it in H2O. We were just talking about it the other day.
Nice.
It's been a minute, but like maybe we could get that into
Yeah.
H2O would be cool.
Um,
Yeah.
so, so that was all super interesting,
Mhm.
but I still don't feel like I know exactly what stacking is.
Oh, okay.
So it's
Yeah. Let me tell you. Let me tell you. Okay, stacking. So it's really simple. So you just cross validate a set of algorithms. Let's say you have 5 algorithms, or like, not 5 algorithms, but 5 models, like a random forest with these particular parameters and a GBM with these, and et cetera, et cetera. And then you
Mhm.
train and cross validate those k times if you're doing k-fold cross validation. And then what you do is then from that process you have the holdout predictions from each fold. And so you have like a prediction for each row in the data, and then you take, so basically you kind of imagine like a new matrix that's your training matrix, and there's still n rows as the original training frame. But now there's just, if you had 5 algorithms, there'd be 5 columns. And each column is just the cross-validated predictions from each of the algorithms. And so you have this new thing, you can stick on the response column, and then you have this new training matrix, and then you train another algorithm to learn how to best combine the predictions from the base learners to predict the outcome. So there's 2 machine learning problems going on: the original one on the original data set, and then this meta learning process. So, and you can use any kind of algorithm you want for the meta learner. Often people just use a GLM, but you could use whatever you want. So it's basically just a 2-level system where you have the base learners, you
Got
have
it.
the meta learner. And then when you go to use that in production or wherever to score new data sets, you
Hmm.
have to score all the base learners, get the outputs, put it into the meta learner, and then get the final prediction. So one of the things that can be slow about stacking is if you have, let's say, hundreds of base learners, and especially if any of them are particularly slow at generating predictions, you're kind of, I mean, hopefully you could do that in parallel. Maybe it wouldn't be a big deal, but you're limited in that way. So um, sometimes people, think it's too complex or something like that. But it's, I don't think it's any more complex than deep learning, and people love that.
Yeah, no, I mean, that is actually quite intuitive. And so I wasn't aware, but so at my machine learning company, Nebula, our main production algorithm is a stacked algorithm. I just didn't know that it was called that.
Oh, nice, nice.
So yeah, so we do exactly that. We have multiple base linears that feed into a generalized linear model
Mm-hmm.
that allow us to have this meta learning output. And yeah, so we kind of intuitively stumbled upon that. We're like, oh, we get in some situations one of these models performs really well. In other situations, this other model performs really well.
Mm-hmm.
Let's try to find a way to have the best of both worlds.
Yeah, I
Um,
feel that it's been discovered independently many times, I think, which is, again, probably why my advisor discovered it and then like proved all the theory behind it. And I'm not, I don't know if he actually knew about it before that actually. So it's become a popular technique on Kaggle. That's pretty much where you see it
mhm,
a
mhm.
lot. But yeah, people are using it. Like a lot of our customers use it.
Yeah,
If you,
it makes a lot of sense.
yeah.
It's like to me intuitively, yeah, as I kind of just explained, like some kinds of models, like a GBM or XGBoost, they happen to excel in particular kinds of situations,
Mhm.
um, and yeah, by averaging together models that excel in different kinds of situations, yeah, it's unsurprising to hear that they're doing really well in Kaggle competitions too. Anyway, I spoke over you.
That's okay. I'm glad you're stacking. You should try H2O AutoML though. That's my pitch.
Yeah, no, for sure. I should probably be using H2O AutoML. I agree. I am based on everything you've said today. I feel like an idiot that I'm not. So yeah, I'll get on it. So in addition to techniques like stacking and of course the H2O library that you develop, what other kinds of tools do you use daily?
Well, I use a lot of R, a lot of Python. There's a new uh, tool that we have at H2O that's open source that's called Wave, and I've been using that a lot lately. It's basically an application building framework, so it's in the browser. So basically, the equivalent that people would have heard of are like Streamlit in Python or Shiny in R. So it's that type of
Yeah.
thing. Um, but I actually do like it better than the other two. Um, I'm not an expert at either of those other two, but I found it to be very easy to sort of make UIs for your models or make UIs for whatever you want. There's tons of like little, you know, built-in things that are already there for you. So you say like, I need this kind of, plot of this nature, and here's the X and the Y and that type of thing. So I've been building
And
a lot with that tool. We're
and
building. Oh, sorry. Go ahead.
does it kind of provide you with like interactive buttons and that kind of thing too for your users?
Yeah.
Cool. Yeah. So of the tools that you mentioned, Shiny is the one that I'm most familiar with.
Hmm.
Um, but so does Wave work with either R or Python, or is it's a Python library?
It's both. I think
Oh, it's both.
the R library is a little bit further behind in terms of some features right now, but so the primarily the library is in Python, and then we have an R API to it as well. So yeah,
Cool.
I've been building a UI for H2O AutoML in it. So that's gonna hopefully come out soon. So it's just like, you know, rather than writing code, I'm trying to get even more one level beyond that. And then you just click to like upload your data set, and then it trains, and then it will also combine all the automatic visualization. So you get like everything all at once just by clicking. And there's lots of, little tabs. You can click on the different areas. It's kind of fun to build that. But yeah, other
Nice.
tools, yeah, I don't know. I use a lot of R, Python, Bash. Yeah, that's about it.
Cool. Well, I'm delighted to learn about Wave, which I hadn't heard of before. So I've learned about a whole bunch of new techniques and approaches in this episode. Wave, admissible machine learning. Yeah, even the driverless package, I wasn't aware of that before. So some really cool things coming up for me and probably a lot of our listeners. Great to learn about how I could be using Wave in Python or R to be building applications in a click and point way for my users in the browser. I've loved doing that with R Shiny in the past, and so it's nice for me to now know about one that I could be doing that with Python applications as well. It allows me as a terrible software developer to be able to have interactive data science applications made easily. And yeah, like fun dashboards, you can typically whip them together pretty quickly. So yeah, it's definitely a tool for our listeners to check out. And so speaking of my terrible software developer skills, I noticed that H2O has lots of engineering roles open right now that I would not be qualified for. So when you're hiring software developers or data scientists, Erin, what do you look for in the people that you hire?
I would say like, are they, what's their experience? Have they been doing this a while? Are they new? I mean, I do also have interns that are, in college and we're able to still get a lot done. Actually, my intern, who's in New York, he was the one that sort of started to build the H2O AutoML Wave app over the summer. So yeah, I think it depends what I'm trying to hire for, but generally like, I highly prioritize if the person is nice and they don't seem like they're going to cause any major drama or issues. That's especially as a woman, it's important to screen for stuff like that. Some any kind of red flags in those departments. But yeah, I mean, I would say like at H2O we do hire a lot of Kaggle grandmasters. That's like an easy way to like show that you know
That's
what
the
you're
easy
doing.
way. Oh, sorry. I was
Like,
gonna say, the easy route to a job at H2O is to be one of the top performing people on Kaggle on the planet. That's the easy way.
Yeah. But we do, that's just one subset of the company. So we have engineers like all over the world. So it doesn't, we have positions open, I think, pretty much anywhere. We're a very like remote company, especially since COVID. So, depending on what they're trying to work on, because we're building this whole cloud right now. So like we're hiring a lot of cloud engineers. I would just hope they've worked on some other cloud before. That would be good. But for data scientists, I mean, you don't need to be a Kaggle grandmaster. You do need some way of like demonstrating your skills and ability to like think through a problem. There's different ways that you can kind of test for that. But yeah, I think programming ability is important because you don't want to be kind of slowed down by that. But it's, I would say, not the most important thing. Like, it's just, I look for people that are, more generalists and can kind of adapt to whatever it is that we're working on. Unless you're, I'm hiring for a specific position where they like have to know Java because they're going to be working on the H2O core or something like that. So, yeah, I think also great, like if people are on Twitter and talking about data science and like promoting knowledge, I think that's a very appealing, especially at a company which has a lot of open source at it, to hire people that would like to do that kind of work as well.
Yeah, that makes a lot of sense to me. And that's something that for listeners that are looking for a new opportunity or maybe their first opportunity in data science, getting comfortable writing tweets or LinkedIn posts or Substack newsletters, whatever, it doesn't need to be at the start the most groundbreaking insights, but just getting into the habit of articulating new things that you've discovered or cool technologies. This makes you more confident about being able to communicate these things, and it forces you to understand them better than if you just read about them And so even if you never got a single Twitter follower or a single LinkedIn follower or whatever, it would still be really valuable when you come to interviews. But then as it happens, if you do it regularly, you'll probably iterate and improve. You'll figure out what kinds of content that you create resonates with some of your listeners, or listeners in my case, readers in most people's cases. And you can iterate from there and start to create more of that stuff that resonates. And yeah, over time, you probably will just develop a following organically while practicing your ability to communicate and understand complex data science concepts. So I, yeah, again, using that same phrase that I used at the beginning of your episode, but preaching to the choir a bit about evangelizing about data science. But I certainly agree. I think it's something that everybody could be doing and would probably benefit from doing. So we've talked a lot in this episode about AutoML. We've had some glimpses into really cool emerging approaches like admissible machine learning. So, Erin, I'd be interested to get your take on how you think data science will evolve in the coming years and decades, perhaps because of things like AutoML, stacking. And so, how can data scientists, what actions could data scientists be taking today to prepare themselves for the data science job of the future?
Yeah, that's a good question. I think like we can kind of look at how the field or position has evolved maybe over the last 10 years. Like if you think about 10 years ago, it was, people needed to be good at 5 or 6 or 10 different machine learning libraries because, or, there was still scikit-learn, but like, if you needed something else, like everything was kind of a little bit disjointed. Some people are like, I remember just talking to a lot of people that are implementing their own algorithms, even though there's like other open source things available. So I think like the data science job has started at like implementing algorithms. Then it's like, okay, now we have kind of scikit-learn or whatever. So then that makes it a little bit easier. But now I'm still like doing a lot of the tuning or whatever fancy stuff that you want to do to get good models. And then now we have more tools that kind of automate that process, like automated hyperparameter tuning, that type of thing. So then that became less important. And then, I think now we have AutoML as well. So it's just kind of like it keeps getting a little bit more automated each time. So I guess what we could expect next is we have, I guess I don't, I don't know what comes after AutoML. I think it's more like using the insights from the models and like really expanding in terms of like explainability and interpretability and all of that, fairness, bias, like all of these topics that were sort of way too niche and like sort of overlooked in the past. Now we have more time to do that. Like if you don't have to spend all your time training models, you can actually think about problems better. Like even when you're starting out a problem, like how to structure the data in the data warehouse or things like that. So I mean, I would hope that people could focus on fairness issues and explainability, and I think that's going to go a long way because there's still kind of this disconnect between like the business or whatever other application of machine learning, like if it's in science, et cetera, and like the data scientists, there's still that gap. And so whatever can like better fill that gap with these different new methods, I think that would be good to focus on.
Yeah, that's a great answer. I love that idea that because we're trending towards increasing automation of parameter tuning, obviously that's kind of machine learning writ large, and then hyperparameter tuning, and then model selection, it should free up time for data scientists to be focusing on the big issues that matter for society, like removing bias, having fair algorithms. These sound like really valuable things for us to be focusing on as data scientists. And
Mm.
so we talked a lot in this episode about approaches related to fairness, particularly when we were talking about admissible machine learning earlier in the episode. But if listeners would like another episode that is largely dedicated to explainable AI, you can check out number 539 with Serge Massis, in which we talked about specific XAI, explainable AI tools. So it could be one worth checking out there if you're interested in learning more about that. So Erin, you have been extremely generous with your valuable time today. The time has finally come for us to start winding down the episode, which means that it's time for me to ask you for your book recommendation.
So yeah, I'm going to give a book recommendation for, I'm actually listening to the audiobook right now, which is Viral Justice by Ruha Benjamin. And she's a professor at Princeton, and she has another book that people might have heard of called Race After Technology. And so she spends a lot of time dissecting some of these issues of like how technology can contribute to racism and how race informs technology, like all the sort of intersections of these two topics. And yeah, she just has I don't know, the book just came out. So a friend of mine tweeted about it and I started listening to it, and it's pretty good. It's also a little bit of a biography, but, or autobiography as well. So yeah, I'm enjoying it.
Cool. Nice recommendation, and ties together a lot of the themes that we have been discussing in this episode. So that's convenient. And then, so Erin, as I've stated in this episode, you are a luminary in the space. You are a extremely well-known content creator in data science, and I'm sure there will be lots of listeners who want to follow what you're up to after this episode. Where should they be following you online?
Twitter is the main place I hang out. So at LeDell, LEDELL. And I don't spend a whole lot of time on LinkedIn or anywhere else. So that's the best place to find my content.
That's great. That's why I asked the question.
Yeah.
So now people know where to hang out with you. Yeah, Twitter for sure. We'll be sure to include your Twitter handle in the show notes. Erin, thank you so much for being on the program. It's been a super interesting episode for me. Yeah, thank you for taking the time.
Thanks for having me.
Super informative episode today. In it, Erin filled us in on how AutoML enables you to save time, have cleaner, more reproducible code, get more accurate models, and view model leaderboards that can deepen your understanding of individual ML techniques. She talked about how XGBoost and gradient boosting machines are often the most accurate ML approaches, but how the no free lunch theorem postulates that no one particular approach is optimal for all problems. She talked about how admissible machine learning relies on information theory and non-parametric methods to quantify how much sensitive variables are influencing a model's outcome via its predictors, potentially enabling the identification and removal of model features causing unfairness. She talked about how stacking multiple base learner models under a meta model, such as a GLM, will outperform the accuracy of unstacked models, and how the open source H2O Wave software library enables you to quickly build interactive browser-based UIs in either Python or R. As always, you can get all the show notes, including the transcript for this episode, the video recording, any materials mentioned on the show, the URLs for Erin's Twitter profile, as well as my own social media profiles at superdatascience.com/627. That's superdatascience.com/627. Every single episode, I strive to create the best possible experience for you, and I'd love to hear how I'm doing at that. For a limited time, we have a survey up at superdatascience.com/survey where you can provide me with your invaluable feedback on the show. Again, our quick survey is available at superdatascience.com/survey. Thanks to my colleagues at Nebula for supporting me while I create content like this Super Data Science episode for you. And thanks, of course, to Ivana, Mario, Natalie, Serge, Sylvia, Zara, and Kirill on the Super Data Science team for producing another phenomenal episode for us today. For enabling this super team to create this free podcast for you, we are deeply grateful to our sponsors. Please consider supporting the show by checking out our sponsors' links, which you can find in the show notes. And if you yourself are interested in sponsoring an episode, you can find our contact details in the show notes as well, or you can make your way to johnkrohn.com/podcast. Last but not least, thanks to you for listening all the way to the end of the show. Until next time, my friend, keep on rocking it out there, and I'm looking forward to enjoying another round of the Super Data Science podcast with you very soon.